Okay, looking at some slightly more complicated reactions now. These are what we call single replacements. So what happens here is we have a couple. We have a compound with a positive and a negative ion in it. And then something new comes along, and two of these elements are going to switch. So you don't have to do this, but I'm going to color code the first couple of these just in case it helps. What we have here is potassium is a metal, and sodium is a metal, and then chlorine is a nonmetal. So when one of these reactions happens, a new metal that comes along will take the place of the old metal, or if a nonmetal were here, it would take the place of the old nonmetal. So what's going to happen here is the original compound was NaCl. The K is going to take the place of the Na because metals can only replace other metals. So what do we get when that happens? The potassium goes in that spot with the chlorine, and the sodium gets kicked out. It will be alone when this is over. So our new compound is going to be potassium will react with chloride, and then we'll have sodium alone by itself. Now, in this case, this works out really nicely, but it won't always. They were nice to us on the first question. Here, these charges match, and so our new compound is simply KCl. But you'll see in a few moments that doesn't always happen that nicely. So we get KCl, and then we have Na alone. All right, so the old couple, new metal comes along and steps in, takes the place. Here's the same sort of idea again, and I'll only do the color coding one more time because it's a little time consuming and maybe you don't need it. But if you love it, feel free to do it in your questions until you get comfortable. We have sodium, a metal. We have calcium, a metal. And then we have bromine, a nonmetal, is the second half of this compound, Br. So again, the sodium is going to step in and take the place of the calcium, and the calcium will get kicked out. Sodium will go there, calcium gets booted. So what do we get now? Sodium ions are plus ones. Bromine ions or bromide ions are minus ones. And so, oh, this is nice. Again, the charges match, and so we just get NaBr. That probably won't keep happening for much longer. And the calcium, which has been kicked out, we write simply as Ca. All right. You can lose this stuff after you're done, and so that's our new reaction. New metal takes the place of old metal. Now, I fibbed. I'm going to color code one last one because this one is different. Here we have sodium is a metal, but oxygen and sulfur are not. Oxygen is a nonmetal, and so is sulfur. So in our first two examples, a metal came along and kicked out the old metal. In this version, a nonmetal, the oxygen is coming along, it will kick out the sulfur instead. So after this is over, we'll have sulfur alone. So our new combination is we have sodium ions, that's Na plus, with oxygen ions or oxide ions, which are minus 2s. How do we make that work? We're going to need two sodiums. This will be Na2O. And the other thing that happens is we get sulfur kicked out. What goes here? Anything? Sulfur, when it's alone, forms clumps of 8 atoms. So sulfur is actually S8. So that's our finished. The new nonmetal comes along and kicks out the old nonmetal. And now they start doing it in English. Zinc metal, plain old zinc, reacts with, tin fluoride. Tin is Sn, and they say 4, so we know it's 4 plus. Fluorides are minus 1s. So for this to match, we'd need a single tin with 4 fluorides on it. Tin fluoride is SnF4. Now what happens? Zinc is a metal. Tin is also a metal, so the reaction that'll happen here is the zinc will kick out the tin. The zinc will end up with the fluorine, and the tin will end up alone. So our new combination is going to be, we'll get zinc ions, which are always plus 2s. We'll get fluorides, which are minus 1s. So the combination will be ZnF2. And tin is now alone, so we get Sn. And metals by themselves are always just the single symbol. They're never diatomic or anything like that. So zinc and tin 4 fluoride produces zinc fluoride and tin metal. Okay, what now? Oxygen reacts with lithium chloride. So oxygen, diatomic, meets metal and a non-metal. We don't know what that is until we do our mental math. So lithium forms +1 ions. Chloride forms -1 ion. Oh, so this is easy. It's just LiCl. So what happens when these meet? Oxygen is a non-metal, so the only way it can break into this couple is by kicking out the other non-metal. Oxygen will take the place of chlorine. Chlorine will get kicked out. So what does that leave us with? The new combination over here is we're going to have lithium ions with oxygen ions. How does that work? These charges don't match. We need a second lithium. So the new combo is going to be Li2O. We need 2 lithiums to gang up on a single oxygen for that compound to work. And now that the chlorine's been kicked out, chlorine by itself is diatomic. It's Cl2. It makes no difference at all that there was only one chlorine before. As soon as chlorine is alone, you have to think about what does lone chlorine look like. It's diatomic. If you have lone sulfur, it's S8. If you have lone oxygen, it's O2. If you have lone chlorine, it's Cl2. So oxygen met lithium chloride. The oxygen kicked out the chlorine. Now we have a new couple here, and we have sad, lonely chlorine. What is this? Nickel meets sodium nitride. What happens here? Sodium is a metal, so is nickel. So when these react, the nickel will kick out the other metal, the sodium, and we'll get the sodium by itself. So what are the new things we have to make? Here we have nickel. Now this gets interesting. What ion is nickel? You can look it up on the periodic table, and what you find, it's element number 28, is there's 2 ions for it, and we don't know which one to use. But actually we do, because when the table gives 2 charges, like for nickel it says +2 and +3, they always say that the first ion is the more common one, and if you don't know what else to guess, you take the first one on the list. So because nickel gives the +2 first, we will assume that our nickel ions are +2s. Nitride ions, nitrogen ions, are -3s. So this is one of those awkward guys where we have to go to 6. We're going to need 3 nickels to make this work and two nitride ions. So our new compound is going to be Ni3N2. And now we have sodium by itself, and because sodium's a metal, we just write Na and we're done. So sorry that got a little untidy, but nickel, the metal, kicks out sodium, the other metal, and takes its place. And every time that happens, you have to recalculate charges. It's a minor nuisance, but you get pretty fast at it after a couple of weeks. And the old metal that used to be in the compound gets kicked out and is now by itself. Here we have phosphorus and potassium oxide. what happens here. Phosphorus is a nonmetal, so when it sees this compound, it wants to take the place of the oxygen. The oxygen will get kicked out. So what does that give us for our new combinations? Potassium ions are plus ones, K plus. And if phosphorus is coming in here, phosphorus ions are minus threes. So to group those up, we're going to need 3 potassiums with a single phosphorus, and that means we're going to get K3P. So our new couple there is K3P, and now that we've kicked out the oxygen, we get oxygen in its alone state, which is diatomic, O2. All right, so nonmetal kicks out the nonmetal, and we get a new combination, and the oxygen, which got kicked out, is now here by itself. And one last time, cobalt metal. Metals are easy, you just write their symbol. Reacts with, gold arsenide. What is this? Gold symbol is Au, and they told us it's plus 3 charge. Arsenide is element number 33. Its symbol is As, and its ions are minus 3. So, this actually works nice. Gold arsenide is just AuAs. One of each. Lovely. What happens when they react? Well, cobalt is a metal, so when it reacts, it will kick out the gold. And we'll end up with gold by itself. So, the new combination is cobalt with arsenic, and we have to figure out what that means. Look for cobalt on your periodic table, and you'll find it's got 2 possible charges, but the first one is plus 2. So cobalt normally forms plus 2s. Arsenide we know is minus 3. We just saw it. I should be writing 3 minus there, sorry. As3 minus. So to match these up, we're going to have to go to 6. We'll need 3 cobalts. There we are. And 2 arsenics. There we are. That's cobalt 2 arsenide. And that's the new couple, and gold has been kicked out, so now we have gold by itself. Good. Cobalt 2 arsenide and gold metal.